This is Mr. Elmhorst with a help video for the triangle sides inequality theorem. We're going to take a look at two sides of a triangle, two line segments, and see does it always form a triangle with a third side. So with that, we need to look at the first example where we have 5 and 7 together being compared with 8. So we circle the two shorter sides. And then you're going to add the two shorter sides. And then you're going to compare it with the longest side to see if it is true. So if we add up 5 and 7, we get 12. And using the inequality comparison, short side plus short side, is it greater than the long side? And if it is, then it will form a triangle. So 5 and 7 will form a triangle with 8. 5, 7, and 8. So this is true, and yes, it will form a triangle. So example number 2, we have 5, 7, and 10. We're going to add the two shorter sides and compare to the longest side. 5 and 7 is 12. We write the inequality comparison to 10. This is true. 12 is greater than 10, so yes, this will form a triangle. So short side, 5, 7, and 14. So we're going to add those two and compare it to the longest side of 14. 5 and 7 is 12. Is 12 greater than 14? So you got 5, 7, and then 14. 14 is too long, so 12 is not greater than 14, so this will not form a triangle. So this is a false statement. 12 is not greater than 14. So no, it will not form a triangle. Short side, find the two smallest numbers and then compare to the longest number, or the longest line segment. So 5 plus 5 is 10. 10 compared to 7, this is true. 10 is greater than 7, so yes, it will form a triangle. 5 and 5 are both shorter than 12. So we're going to add the two shorter numbers and compare it to the longest line segment, the two smaller numbers. That's 10 compared to 12. 10 is not greater than 12, so this is false. No, it will not form a triangle. We're going to move on to the Ed puzzle. If you have not seen the Ed puzzle at this, for not being in class, you can watch the Ed puzzle to help you out with these examples. We're just going to recap here real quick. So find the two smaller numbers. And you're going to label them. 4 and 4 are the two smaller numbers. You're going to add them and then compare it to the largest number. 4 plus 4 is 8. And 8 compared to 7. 8 is greater than 7, so this is true. So 2, 4, 6. 2 and 4 are the smaller numbers. So we're going to add those and compare it to 6. 2 plus 4 is 6. And we need something that is greater than 6. But 6 is not greater than 6, so it would not form a triangle. It has to be greater. 3 and 4 are both shorter or smaller than 9. You're going to add up the two shorter sides and then compare to the longest side. 3 plus 4 is 7. 7 is not greater than 9, so this would not form a triangle. But if we took the 9 away and put in a 5, 3 plus 4 So we're going to compare short side to short side. Add the short sides and compare it to the long side. So that's going to be 7 is greater than 5. So when you use 3 and 4 with 5, then yes, it will form a triangle. 3, 4, and 5, that would work. So this is true. 7 is greater than 5, so yes, it will form a triangle. Okay, so once you go on to the back, first you're going to do is find the two shorter sides, the smaller numbers, and then add them. Okay, 17 and 25 are the two shorter sides. And we have 11 and 20 are the two shorter sides over here. So you're going to add them up. So 20 plus 11 is 31. And we're going to compare that to 32 for the long side. 20, 30, well, it looks like 42. 25 and 17 together is 42, and then we compare that to 29. So this is true. 31 is not greater than 32. This is false. Number 4, this is true. That would work. 8 is not greater than 16, so this is false. 3 plus 8 is 11. This is true. And 34 is not greater than 37. 13 plus 21 is going to be 34, so this would be false.